What I find exciting about being a scientist and being in general and being an astronomer in particular is that there are times when I have figured something out that nobody else on the planet knows. You know, I'm the only human being on this planet who knows this thing. And it's just kind of cool. You've learned something completely new about the universe. I'm Deidre Hunter. I'm an astronomer here at Lowell Observatory. I work on the tiniest galaxies in the universe, little dwarf irregular galaxies. Galaxies are collections of stars and gas and dust, all held together by gravity. Dwarf irregular galaxies are just teeny tiny little galaxies that are maybe 10,000 fewer stars or even less.
The tiny irregular galaxies that Deidre Hunter is studying contain a profound mystery. The birth of a star, according to accepted models, can only happen in a large galaxy with a critical density. Dwarf irregular galaxies don't have this density, and yet we can see stars forming inside them.
What I would like to do is answer the big question for dwarf irregulars, which is, how do they form clouds that form stars? If you look at the sky at night, you see all these stars in the sky, and we tend to think of the space between them as being empty. But it's not. It's full of this very tenuous gas. Occasionally, this gas will come together into a cloud, and then gravity pulls it together further, making it a dense, cold cloud. So then the stars form out of those kinds of, they're called molecular clouds.
To understand more about how stars form in these cold molecular clouds, Deidre will head to the Discovery Channel telescope, where she waits for the sun to go down to set up on a galaxy where she hopes to find some answers.
648. The galaxies that I've chosen are a subset of a sample that's part of a project called Little Things. I'm using the camera to take images, and the purpose of these images is to go very, very deep so that we can study the outer disk of stars in these galaxies. I observe in through four different filters from the ultraviolet, blue, green, and red, and the purpose is to see what kinds of stars are out there. By looking in dwarf galaxies, we're looking at an environment where star formation isn't explained by the current models. But if we look in the far outer disks of dwarf galaxies, we're looking at an even more extreme environment. And so if we can look out there, if we can see star formation going on out there, then we've poked a really big hole in the models.
For Deidre to go deep enough to see star formation in the outer disks, she will spend 2.5 nights to get the full spectrum of a single galaxy. The answers Deidre is looking for in these dwarf galaxies could also have implications in other questions about our universe, as for example, how it began.
In the early universe, when the first stars formed, they formed out of a gas that was primarily hydrogen and helium atoms, and not any of the heavier elements like carbon and nitrogen, oxygen that we see so much here on Earth. So that raises the question, well, how did those first stars form then without the benefit of those heavier elements?
The gas around the first stars would have been pristine, nothing like the gas we have now in the Milky Way. The closest thing we have to that kind of gas is what you find in dwarf irregular galaxies. If we can understand more about star formation in dwarf irregular galaxies, we might come that much closer to understanding the mystery of how the very first star in the universe was born.
And you can see that you can see why you have to expose a lot if you want to go really deep, because the galaxy's in here, but you can't actually see it. Now, it's not something you discover, because it's not just going to happen overnight. I've been working on it for over 30 years already, and so it's just something that you work at. You do one thing and then you do another, and you think of something else, and you do this and you do this, and you just try and put all these pieces together over time and hope that eventually you can make up a picture that actually makes sense. But there's this little tiny dwarf irregular galaxy, and it has a little bit of star formation going on it, but not a whole lot. So, all of it together is just, it gives us a sense of our place in the universe. We went from this big bang where there was nothing but some atoms and dark matter to people sitting around eating with friends. I mean, what a journey that is. And so, while the dwarf irregular galaxies are only a piece of this whole thing, we're trying to put this big picture together to understand the universe that we're in and understand this journey that our universe is going on and which we are a part of.